Hello everyone. So today we are going to discuss some of the questions which are very important if you are preparing for chapter 10 of class 10. The chapter is light, reflection and refraction. So today we are going to discuss particularly the questions which are related to the reflection part of it, that is the mirrors. Okay, and side by side I will keep on explaining also the reasons behind the answers. So stay tuned and hope that you will understand from the video. So let us quickly move on to question number 1. It says that the angle of reflection is equal to the angle of incidence, right? What are the options? Always, sometimes, under special conditions, or D, never. So if you have done the topic of reflection and you have done the two laws of reflection, so the very first law says that the angle of reflection is always equal to the angle of incidence, no matter the kind of mirror that you are taking. Even if you are taking a plane mirror that whose reflecting surface is plane, even if you are taking a concave mirror whose reflecting surface is curved inwards, or you are taking a convex mirror whose reflecting surface is curved outwards. So in all the cases, the angle of reflection is always equal to the angle of incidence. So this is our option A, which is correct, right? Question number 2, the angle between an incident ray and the plane mirror is 30 degree. Now this is a point where many of the students, they do mistake. They take that, suppose this is the plane mirror, right, and this is the incident ray of light. So you have to read this statement carefully. It is saying that the angle between the incident ray and the plane mirror, so this is the plane mirror and this is the incident ray, the angle between this is given to you 30. So it is not the angle of incidence. Now this is the point where we may do the mistake. Now we have made the normal, and we all know that angle of incidence is equal to the angle of reflection. So I have made this reflected ray as well. Normal with the mirror is at 90 degree because normal is perpendicular to the surface of the mirror. So if the angle between the incident ray and the plane of the mirror is given to us 30, we can apply the formula 90 minus 30 and this will give us the angle of incidence, which is 60 degrees, right? So since this is 60, so we have got the angle of incidence 60 degree, right? So we have got our first part of the answer. Let us read what the statement is saying. The total angle between the incident ray and the reflected ray. So they are not asking you only the angle of incidence or reflection. They are asking you the total angle that will be made. Okay. So if angle of incidence is 60, it's obvious that angle of reflection will also be 60. And the total angle would come out to be 60 plus 60, that is 120 degree. Let us see, do we have such option? Yes. So our option number D is the correct one. The important thing here is to understand this part of the statement, that the angle between the incident ray and the plane mirror is 30 degrees, right? So second question is done. Moving on to the third one now. A ray of light is incident on a plane mirror, making an angle of 90 degree with the mirror surface. Okay, so suppose this is our plane mirror. This is the polished side, which is shown with these oblique lines. So this is the polished surface of the mirror, and the upper one becomes the reflecting surface. And whenever we talk about a mirror, it is the reflecting surface which is more important to us. So they are saying that the incident ray of light is falling on the plane mirror, making an angle of 90 degree with the surface of the mirror. So this is how the incident ray of light is falling. It is making an angle of 90 degree with the mirror surface. The angle of reflection in this case will be, now again this is a very good question because it is based on our concept. Many of you will say that, following the first rule of reflection, that since I've just now told you angle of incidence is equal to angle of reflection, so if incident ray is falling at an angle of 90, you will say that reflection is also 90, but you will be wrong over here. See beta, what we need to understand, that whenever we talk about the angle formation, angle is always made with the normal, right? So suppose this is the normal, and how do I know that this is my normal? Normal is always perpendicular to the surface of the mirror, right? So this is the normal. If this is the incident ray, then you all can see that a small arc is getting formed between the incident ray and the normal. This is the angle of incidence. So what do we understand? That angles are always made with the normal. Now in this case, can I say that the incident ray and the normal, they are coinciding with each other? Like This is how the normal is. It is also 90 degree perpendicular to the plane of the mirror. And on the same area, the incident ray is also falling on the same place. So what is happening? That arc is now getting reduced to 0. So now in this case, angle of incidence is not 90, it is 0 degree because incident ray is also falling normally to the surface of the mirror. And now the angle of reflection will also come out to be 0 degrees, right? So this is only for confusing. Otherwise, if our concept is clear, then we know that angle of reflection in this case is 0. So our answer is C part, which is 0 degree Celsius, right? Moving on to the fourth one now. The fourth question says that the image of an object formed by a plane mirror. Now, this is the second page of your NCERT where 4 characteristics of image formed by a plane mirror is given to us. First characteristic says that the image height is always equal to the object height, right? Suppose object is of 5 centimeter, image will also be of 5 centimeter, right? And we can take one example, like in our homes, we have plane mirrors. So if we are suppose 5 feet tall, so our image will also be 5 feet tall. So it will not be like smaller than that, right? So height of image is equal to the height of object. Now, suppose the object is 10 centimeter in front of the mirror. The image is formed 10 centimeter behind the mirror, okay? So object distance is equal to image distance. Object distance is denoted by U and image distance is denoted by V. Third is that the image formed is virtual and erect. Now what do we mean by virtual and erect? Virtual means from the mirror you cannot bring this image to a screen. You can only see this on the mirror, right, behind the mirror. But from the mirror you cannot take it on any other surface, like you cannot produce it on a wall or you cannot take it on any other plane surface. So that is the meaning of virtual. You can only see that on the mirror, but you cannot take it on the screen from there. And erect means, suppose like we are standing head up and legs down. So our image will also be head up and legs down. So that is called as erect. The way you keep the object, the way you get the image. So if you are clear with these three, the fourth one and the last one is that the image formed is laterally inverted. And you all know what is lateral inversion. When right of an object appears to be the left in the image, or the left of the object will appear to be the right of the image, right? So basically left appears to be right and right appears to be left. That is called as laterally inverted, and I need not tell you a lot about it because everybody is clear with the example of ambulance, how that is written on the vehicle. That is for lateral inversion, right? So now let us move on to the question and let us hope that we will get our answer if we keep all these 4 characteristics in our mind. The image of an object formed by a plane mirror is virtual. I guess this is close to the answer because we have done it in point number 3rd, virtual. Real is not correct because we cannot take it on a screen. Diminish is also not correct because the very first point we have done, height of the image is equal to the height of object. And is it upside down? Upside down means that if you keep an arrow like this, will you see the arrow down? So no, we are not going to see that down. Upside will be upside and down will be down. So this is also wrong. So which is our answer over here? 4th one. Very, very easy, directly from the NCERT. Then moving on to the 5th one. The image formed by a plane mirror is, right? Now again, those 4 characteristics we will use that we have done just now. If you have forgotten, you can just move back in the video. You can see that and then we can come to the answer. A says that virtual, behind the mirror and enlarge. So I guess virtual and behind the mirror is correct, but enlarge is wrong. Virtual, behind the mirror and same size as the object. I think this is our answer, but we should never come to the conclusion. Once we have to read all the 4 options which are given. It is real, that is wrong. At the surface of the mirror, that is also wrong because the image is formed behind the mirror, and enlarge, that is absolutely wrong. Real is wrong, behind the mirror is correct, and same size. So you all can see that in A, C and D part, one or more things are wrong, but in B part everything is correct. So our answer over here is B. 5th, the answer is B. Now, Sixth is very important, and if you see bete, we have discussed question number 4, 5, and now we are moving on to 6, and these three are related to nothing but the image formed by a plane mirror and their characteristic. So what do you understand, that all the 4 characteristics are given to you in the NCERT, but how that has to be applied will depend on your understanding. Okay, so let us read the question. It's a very beautiful question. The question says, the figure given alongside shows the image of a clock as seen in a plane mirror. So it is actually the image of a clock as seen in the plane mirror, right? We are seeing this image in the mirror. It's not the actual clock, but we are able to see that in the mirror. Okay, and in the mirror, what do we see? We see that the time is coming out to be okay, the correct time is, now we have to see that what the correct time is going to be, right? So suppose the mirror is kept over here and this is the image that we see. Okay, never come to the answer just by looking at it. At least we should try to get the answer. So the clock will be like this only. We'll see the black portion like this, but you know that there is lateral inversion. Due to lateral inversion, this is the right of the image and this is the left. So now the left will appear to be right and the right will appear to be the left will appear to be right and the right of the image will appear to be left. Okay, so if we see, let me just put the markings. This is how every number will appear to be. This is the right side of it and now it will appear to be the left. So this will be something over here and this is the left. So this will now appear to be right and this will be something here. So this is the actual wall clock that is kept. Remember that left appears to be right. Okay, this was the left. It is appearing to be the right of the object and this is the right of the image and this is appearing to be the left of the object. Okay, so if you have a clock and you get a time like this, I think it is 9:25. Okay, even if still you have some doubt, you can again watch this and come to the conclusion. What is lateral inversion? That the right of the image will appear to be the left and the left of the image will appear to be the right. Clear? This is how it will be, right? Now, moving on to 7th question. In a convex spherical mirror, reflection of light takes place. Now, it is a convex spherical mirror. Now, what is a convex spherical mirror? A spherical mirror whose reflecting surface is curved outwards. You all can see it is curved outward. This one is the polished surface. So where does the reflection of light takes place? You always should know reflection is only associated with the reflecting surface. Is it at the flat surface, a bent in surface, a bulging out surface or an uneven surface? So I guess the answer is C part, that is the bulging out surface, right? Then 8th one, a diverging mirror is, what is a diverging mirror? Diverging mirror, a convex mirror is also called as a diverging mirror, right? So this is a convex mirror and it is called as a diverging mirror. Now why do we call it as a diverging mirror? Because if we have an incident ray of light parallel to the principal axis, right, after striking the reflecting surface of the mirror, the ray of light will bend away from the principal axis. Now because the reflected ray is going away from the principal axis after reflection, that is why it is called as the diverging mirror. So our answer is going to be convex mirror. Plane mirror is not diverging, concave mirror is converging, and here they have tried to confuse us by writing shaving mirror, and shaving mirror is nothing but a kind of concave mirror only. Okay, so I am telling you that it is nothing but a concave mirror, so our answer is B part. Moving to the ninth one, if radius r is the radius of curvature of a spherical mirror, focal length is f, then what will be the focal length? Okay, so they are asking that what is going to be the focal length, right? So focal length, right, let us all see that. So I need to first tell you that suppose I am considering the example of a concave mirror. The center of the reflecting surface of the mirror is called as the pole. The center of the hollow imaginary glass sphere from which the given mirror, of which the given mirror is a part of, is called as the center. And the center of pole and center of curvature will give us the focus. The distance from the pole to the focus is called the focal length, and from pole to the center of curvature is called radius of curvature. So you all can see it over here only, that radius is twice of f, and they are asking that if r is the radius of curvature of a spherical mirror and f is the focal length, then we have to pick that which one is correct. Now over here, I guess by mistake there are two answers that we are getting, but suppose that one of the answer was 1 by 2f, then our option B would have been correct. But in this case, all the B and C options, right, they are correct because radius is nothing but twice the focal length. Suppose focal length is 15 centimeter. So you should know it yourself that radius of curvature will come out to be 30 centimeter, right? So radius is always double the focal length, twice. 10th, the focal length of a spherical mirror of radius of curvature 30 centimeter is. Now they are telling that radius of curvature is 30 centimeter. What is the focal length of it? So if you have just listened to me properly, then you all know that radius is twice the focal length, and focal length will be nothing but half of the radius. So what is the half of radius? It will come out to be 15. Option B is the correct one. 11th, if the focal length of a spherical mirror is 12.5 centimeter. Now they are telling us the focal length, which is 12.5 centimeter. What will be the radius of curvature of it? Now we all know radius is nothing but the double of focal length. So if focal length is 12.5, the double of it is 25. And if we see the options, option A is giving us the correct answer, which is 25 centimeter, right? 12th question, moving on to the 12th one. I hope till here everything is clear. 12th one, now we are moving on to the ray diagram questions. And one thing we all should know right in the beginning, we have done the ray diagrams for concave mirrors as well as for convex mirror. Just as a memory tip, we all should know that there are 6 ray diagrams in a convex mirror. In the very first case, the object is kept at infinity and its image will be formed at the focus. And that will be highly diminished image. It will be point sized. And now as you will keep on going from infinity towards the mirror, the object will go closer to the concave mirror and image will get away from the focus. And as it will get away from the focus, the size of the image will also keep on increasing, right? So let us all now check it out. 11th is done. 12th question. The real image formed by a concave mirror is larger than the object when the object is. Now they are asking that the image is real and it is larger than the object. So where should the object be placed? Should it be at a distance equal to radius of curvature? Radius of curvature means they are talking that the object is at center. Now when the object is at center, the image is real, but it is not larger because image is same size as that of the object. So it means that our option A is wrong. At a distance less than the focal length. Less than the focal length means they are talking that the object is between F and P. Now in this case, the image is larger, but it is not real. So it means that it is also wrong. The Object is between focus and center of curvature, that is F and C. Now in this case, the image gets formed beyond C. The image is large and it is real. So by far, I think our option C is the correct one. But let us give a quick look on the D one also. At a distance greater than radius of curvature. Greater than radius of curvature means they are talking that the object is beyond C. Now in this case, the image is formed between C and F. That is real. It means the first part is correct. But the image is not larger, image is diminished. So our answer is option C over here. D is also wrong. Moving to the 13th one. The real image formed by a concave mirror is smaller than the object if the object is between center of curvature and focus, that is between C and F. In this case, the image is larger and it is real. So it means that it is wrong. At a distance greater than radius of curvature, it means they are saying beyond C. Now in this case, the image is formed between C and F. It is real and it is diminished. And smaller means diminished only. So I think B should be the correct one. Let us have a look on to C as well. At a distance equal to radius of curvature, this is wrong because though the image is real, but image size is equal to object size. So it is wrong. And at a distance equal to focal length. Now focal length means you are keeping the object at focus. The image is real, but in this case, the image is highly magnified. It's not small. So D is also wrong. So as per our calculation, option B is the correct answer in this case. Moving on to the 14th question. Now 14th question says that the image formed by a concave mirror is virtual, erect and magnified. Now, you know beta, in concave mirror, 6 ray diagrams we have done. Out of the 6, in the first 5 cases, the image is real. It's only the last case when the object is virtual, right? And that is when the object is placed between pole and focus. The position of the object is at focus, no. Between focus and center of curvature, not at all. At the pole, you cannot keep any object at the pole because pole is a part of the mirror. It's the center of the reflecting surface of a mirror. And between pole and focus, so yes, absolutely that is it. And you know, even if you read this one for a concave mirror, virtual and erect, it means between P and F. Okay, so that is a very easy one. Moving on to the last question of today's video. This video will be done in 2 parts. So this is part 1 and I will end up this with question number 15th. The image formed by a concave mirror is real, inverted and of the same size. Now this same size is also a hint. Same size as that of the object is only possible when the object is kept at center of curvature. The position of the object must be at focus, no, because when you keep it at the focus, image is highly magnified. Between center of curvature and the focus, not at all, because in this case, the object is kept between C and F, the image will be formed beyond C, but it will be enlarged. This is also wrong. At center of curvature, so we got our answer, but let us read the D part. Beyond center, no, the image will be diminished. So in this case, our answer is option number C. So I think what you have understood, if we pay attention to the concept and we do it properly, everything becomes easy for us. Only thing is how we have to apply. So this was part 1 of the video. Part 2 will be shared with you later. Thank you for watching. Thank you.